Mm. Hello everyone. So since this is the first class, I am waiting for some more students to join. So just few more minutes. Hi. So we will start the class today. So welcome to the first class for the live session of Signals and System. So this course is offered by two professors, and I will be acting as a TA for week wise. So suppose you have doubt in particular week. So this was for the first week. You can ask your questions here in this the first week live session. So myself, Annu, I am PMRF PhD scholar from IIT Hyderabad. So I have prepared some of the slides for today's class, and I would like to tell you that how the course structure will be for my class. So this will be the 2 hour class every Saturday, and here you will have the revision of the whole week class, and also you will have some of the Python exercises to do. Like I will show you how the signals look like, what are the role of mathematics in signals through Python code. And this will not only restrict to only the course content, but we will also see some of the practical examples through Python code. I have chosen Python for several reasons. One of the reason is it's so easy, and second is you I can teach you some sort of Python also. And in future signals and system, if you say, this is particularly driven by the AI/ML applications, and so that's why for AI/ML Python is widely used. So the content for today's class will be how the mathematics and signal systems looks like, then what are the real and complex numbers and sinusoids, how there's limits and continuity. I think I have taken the same sort of things that is being covered by the professor in the NPTEL class, but obviously the content will be different. It will not be the same. And here, in this class, I will teach you how to solve a particular problem. Okay. then differentiation integration, then input output relation for some of the RLC circuits. I will directly go to the formula based because I am here to teach you how to solve a then unit step and delta function, then real and complex numbers. Okay, again the same sort of things repeats. And here that these are some of the Python codes, and the other things are simply the theory. So if we talk about, you may wonder, what is the role of mathematics in signals and system? Okay, so first of all, what is signal? Okay, so if we see some physical quantity that varies over some independent quantity is called signal. So signal can be in the form of any values, okay, that can be current, voltage. That's why professor told some of the example using uh Kirchhoff's law, voltage, current, like that. So I will tell you anything that varies with respect to time is actually a signal, or it can be temperature, it can be a pressure. But here we are talking about time. So physical phenomena that varies with respect to time, okay, that is signal. So you often have come across some of the stock market. Okay, so how we represent it? So the stock price is y-axis and the time is the x-axis. So it varies somewhat, some up, down, up, down. So we call that as a stock price signal. Similarly, physical quantity is represented in terms of signal. This is the basic course, and it is also like the explanation is there in Hindi. Okay, but to reach to a higher audience, if you say I can speak in Hindi, if you don't understand, but to reach a higher audience, I will rather stick to English. Okay, so if you see, signals can be expressed using real and complex numbers. So, for instance, a sinusoidal signal is represented as xt is equals to a cos omega t plus phi. So any sinusoidal signal have the amplitude as a and frequency as omega and phase as phi. So if I say, if I represent, you may wonder what is a, what is pi, and what is omega. So this is x, p, this is p. So I'm talking that this is the pi, is this phi. The angle which creates with respect to anti-clockwise direction with respect to t. Omega is the frequency, that is the harmonics, and t obviously this. Also, okay, whereas amplitude is omega's angular frequency, this is angular frequency, pi is the phase. The exponential signals take out the form e power st, whereas is sigma plus j omega. Okay, the Fourier series that we talk about, talk in detail. Obviously, it will be detailed, covered later, because this has application over decades. Okay, I will tell you some of the applications so that you will never forget this type of things. So here we will talk about the tricks also. How can you represent signals and systems? And I'm very sure that if you join my class, you will not regret that I don't know, or if I don't remember some things. Okay, you will know how to remember the things. Okay, so that is the Fourier series. So here you can see how maths are being covered. Okay, so what I mean to say is summation. Excuse me, my health is not that good today. Xt is equals to summation of Cn e power j omega naught t. Okay, so if you say xt in terms of summation of some exponential techniques or exponential series, you're talking it as terms of Fourier series. And this word as it represents in the name itself is a series. Okay, so series is always represent in terms of summation. You always remember. Okay, if it is a sequence, then it is an infinite sequence, like 1, 2, 3, like that. This is a natural sequence. Okay, natural number sequence. But it's not a summation. If we talk about series, it is a summation. This is also infinite. Okay, this is infinite. Series is also infinite, but is represented in terms of summation. Similarly, Fourier transform. Fourier transform, the name suggests, the only similarity between Fourier series and Fourier transform is only the scientist's name. Other than that, it is no similarity. So Fourier series is actually the way of representation of signal in the time series only, whereas Fourier transform is a representation of way of representation of signal in the Fourier transform, means frequency domain. So you are converting the time series data to the frequency series data. That is the way of Fourier transform. And how will you do that? If you have input as xt, this gives, the formula gives as xt power j minus 2 pi f t dt. This is the signal in frequency domain. Now we talk about signals. What is systems? Okay. So basically the continuous time systems. So systems are nothing but we will talk about, for the sake of simplicity, LTI systems. So the LTI system, which is a system analysis, is being done, or most oftenly done, using differential equation. Okay. So how the differential equations are being used in the systems, I have just given an example, where the state space representation utilizes linear algebra, which is the base of everything. Here I represent everything, means AI, where U is input, Y is the output. Okay. Now, mathematics of application in signals and system, we talk. So now we talk about what is systems. Now, if we say systems, so you may wonder, why, what will the output of system? So output of system is always represented by convolution. So if I talk about convolution, convolution is nothing but this formula. These formulas you have to remember every time. This is a convolution form. Okay. This is minus infinity to infinity x of tau st minus tau d tau. So what is exactly doing? So you have one signal, then you are multiplying with respect to time reverse property of that particular signal, and then you are summing it. This continuous, if the summation here is equal to same and continuous, it is in discrete. Okay. Now, what is the property of delta function? So this delta function have several properties, and that is also asked in the first week questions. So delta function, if we plot how it looks like. So what it is present at t is equals to 0, the value is infinity. Okay, and at every value it is 0. So this value is 0, 0, 0, 0. Whereas at t is equals to 0, it is infinity. But what we call is the area under minus infinity to infinity is 1. Otherwise, the value is infinity. And if you talk about the discrete time, so the discrete time is, sorry, t is equals to nts. Okay, when we do the sampling of a continuous time signal, then that becomes discrete time. Discrete time is we can define it every time interval. It is not continuous. Okay, then delta n has this value. So delta n is equals to 1 T n is equals to 0, otherwise 0. Otherwise, this is n after converting. Okay, and this is the unit step function, and how it would look like is this is how it looked like. And if we talk about area under UT is 1, is it? No, here it is not defined. Your homework is what will be the area under UTDT? Find it out. And if we talk about the communication systems, because systems specifically communication, how we communicate with each other, how the base station is giving signals to us, how we can call a person and just talk over an hour, more than an hour. How is this possible? How we connect just to dial a number and it goes to a person and the other person picks a call and we are having the phone call. How is that possible? The only thing that is working here is the communication systems, where communication engineers work hard and get these things done for you in order of milliseconds. So the signal is of various duration, okay, as we have known that it varies over time, that is infinite duration also. But we need to do the Fourier transform and transmit over higher modulation. So what does that mean? Modulation is a way of transferring or the way of conversion of a signal from low frequency to high frequency. Okay, very good. So if we say uh, modulation involves phasors and trigonometric identities. For example, amplitude modulation implies this ST is equals to A plus mxt, where m is a modulation order, cos omega ct, where A is a carrier, m is a modulation index, omega c is a carrier angular frequency. Very good. Now, we also define the noise that utilizes the probability density function. So, this two slides was basically on the how mathematics are being involved in signals system. Okay, so Laplace transform are used to analyze the system stability and behavior in the frequency domain, where the eigenvalues and eigenvectors of the system may it is determine the dynamics. Okay, so I will show you some of the codes or the physical things. How can you see some of the signals in real time? So let me show you. So I hope my screen is visible to you. Okay. So first code was the representing and visualizing complex numbers. So suppose you have this import numpy as NP is one of the library that helps you to deal with the arrays. The second library is a matplotlib. There it is. Okay. Matplotlib.pyplot. So this is for the plotting, how we will see. So two libraries you always remember matplotlib.pyplot as PLT or something you can keep, and then numpy as array. Okay, so let us keep some of the built-in functions. So let us keep, I'm keeping Z1 is equals to 3 plus 4, say where 3 is a real part, 4 is a imaginary part. Okay, so using numpy arrays, I'm writing for multiple complex numbers. Okay, Z1, Z2, Z3. Okay, so I'm plotting it. So keeping the sum of the inputs. Okay, title complex number on the complex plane. NP dot real, these are the built-in function. Okay, PLT dot scatter. Okay, then I'm keeping some of the imaginary function, and magnitude or phase plot also I'm keeping so that you'll understand how that looks. So magnitude, again, this is the apps that gives apps in the sense it gives root over a square plus b square, where a z is equals to a plus ib. Okay, so I am also doing some of the addition operations, then multiplication operation, division operations for the complex numbers. So let us see the output directly now. So see, in real time, if this is a scatter plot, that's why it's dot came. So if you see here, you have minus 1 plus 1j, this is the Z3, Z2, Z4, simply it's in a 2D plane. And if you see the magnitude of every Z1, Z2, so this is a phase. Okay, so magnitude is 5. Phase, if you say it's somewhat for Z1, it is 60 or 55 degree. Okay, similarly for Z2, Z3, Z4. So how phase and magnitude looks like. Okay, and after addition, after multiplication, what are the operations? So this is the Z1, Z2. So this is Z1, and Z1 plus Z2 is this one. Okay, and Z1 into Z2 is this one, and Z2 is this. Suppose two vectors are there and performing Z1 plus Z2 and Z1 into Z2. So this is the part of complex and real number. I do hope you understand what exactly it's doing. Okay, so this is the visualization of complex plane, and I'm plotting magnitude of phase spectra. And I'm go to next slide, generating sinusoids and phasors. Okay, now how will you generate a sinusoid or the sinusoid signal? So as we know, we have amplitude, frequency, phase, time, right? So simply we can write this, um, generate sinusoid. We will have amplitude, phase, time. So we have to generate the sinusoid. So suppose amplitude is there, NP dot sine 2 pi ft plus pi. Okay. Similarly, we can plot it also with respect to sine wave and cos wave. So representing phasors, if you want to represent the phasors. So again, the phasor representation is if you write a e power j phi. So I didn't tell you that thing. I will tell you in the notes also. Like if it is a sine omega t plus phi is equals to a e power j phi. So this is a phasor form. Okay. Similarly, if you want to plot the phasor form, then you need to plot the phasors on the complex plane, real axis and imaginary axis. So if you want the phasor operation, suppose phasor 1 plus phasor 2, how will it look like? And if you want to plot the phasor operations, how will it look like? So dynamic visualization or animating phasors is also, I have done that for you. So let us see what are the options. Okay, so this is the sine and cosine. Is it a phasor form? Answer is no. I will tell you what is a phasor form. This is having simple amplitude, phase, and omega. So everything is different. Okay, sine and cosine. So cosine sine you I might have already know, but even if you don't know, you need to understand things. So my screen share stopped. Just a second. Yeah. So this is a sine and cosine waves. Okay. And as I told, what is a phasor for sine? What is a phasor for cosine? So phasor means nothing but e power. j phi. So amplitude will be written as a e power j phi. So that the e power j phi is nothing but the angle of the orientation. So see, for the sine and cosine that we developed, it looks like this. So this is the angle of 90 degree. The difference between the phasor for cosine and sine is 90 degree. Okay. So phasor operations from the complex form. Suppose you have Z1 as sine, Z2 as cosine. How will the sum looks like? So the sum comes in between. See. And also product comes also in between. So these are parallel in nature. So sine, cosine, product comes also in between. And this also comes in between. I hope you saw my previous slides. I don't know whether you saw these programs also or not. These are specifically designed for the week one. Then I will design for the week two also. Okay. So if I go to next Python code, that is evaluating limits using SYMPI. So if I go to the third program, limits, how will you evaluate the limits? This is the code for evaluation of the limits. So evaluates the limit as a given expression as a variable approaches a specified point. So before I tell you about the limits, I would like to share my PPT. So I think two of you joined, Krishna and Kavya. Hi Krishna, Kavya. Can you please tell me about yourself? What is the motivation for joining this course? Have you watched the first video lectures? Krishna, I saw you from the beginning. Kavya, you must have joined now.
Hello, ma'am.
Hi, Kavya. So, have you watched the lecture of first week?
Yes, ma'am.
Okay, good. So, you will give exam for this course?
Yes, ma'am.
Okay, okay, nice. Krishna, what about you?
Yes, madam.
Okay, so have you watched this first week lecture?
Yes, ma'am.
Okay, that's great. So, fine. We will also see some of the actual practical examples for the mathematics involved in the signal processing using Python code. So we will go back to the Python code later. I will tell you the course content briefly, then we will go directly to the questions and answers. So this is a 2 hour class, and I really want every minute of this class uh, should be beneficial to you, because since you might have already watched the lecture, it's well and good. But if you want to revise the things, it's the motivation that you should join this course class. So if I say first part of the class was the real and the complex number that we already saw uh, through Python code, how it looks like. So this operations are very simple: addition, multiplication, and the conjugate. Okay, and it can be represented in terms of rectangular or the polar form. Okay, so e power j theta is nothing but cos plus j sine theta. Okay, so if you want to represent z is equals to 3 plus 4j in polar form, you have to represent first, because the polar form z is equals to 3 plus 4j in polar form is a plus e power j theta polar. Okay, where a is root over 3 square plus 4 square, and theta is tan inverse 4. This is nothing but 5. So this is 5 e power j theta. Simply I have done in the same way. Identify the real and imaginary parts. Real parts is this, that, and theta. Finally, write the polar form. Ensure the argument is in the same correct coordinate based on the signs of real and imaginary. So, what does this mean? Coordinate means, okay, so both are positive. First quadrant with line, second quadrant with line, third quadrant with line, fourth quadrant with line. Okay, so if it is this x, this is fine. Okay, since this is the first, okay, so this was, if this is comes, then it is pi minus theta. If this comes, this is minus pi minus theta. And this comes, then this is minus theta, or if this comes, it is theta. I hope you must know about this. Even if you don't know, then this is the case. Okay. This coordinate means if both are positive. This coordinate means suppose x is negative, y is positive. This coordinate means both are negative. Okay. And this coordinate means y is negative, x is positive. The second part was sinusoid and the phasor. So first we need to represent the signal in the forms of sinusoid and the phasor. So we saw signals in real time. Okay. Phasor concept for simplifying the sinusoidal analysis. So conversion between time and the phasor domain. So how will we convert? So in order to convert this in the phasor form, then cos omega t plus pi by 3. This is actually equivalent to a cos omega t plus pi, which is represented in terms of a e power j pi. So what is that? 10 e power j pi by 3. Okay, if this question comes, you can solve this properly. So same step, we have to identify the frequency, amplitude, and phase, okay, which is not needed for the phasor form. Then next step 2 is express the sinus and its phasor. Then use a phasor for the analysis. Because why we are doing that? We need to do the analysis. Remember that the phasor representation always a time domain term, that is j omega t. Third part was of the lectures was limits and continuity. So if you want to know what is the definition, the properties of the limits, the continuity of a function at a time, and what are the applications in engineering problem. So let us solve this problem. Limit x tends to 2 x square minus 4 divided by x minus 4. How will you solve? So in order to solve for the limit, you need to first simplify it to the maximum form. Okay. You need to use some of the maths here. So since the question is limit x tends to 0, x square minus 4 divided by x minus 2. This goes as x plus 2, x minus 2 divided by x minus 2. This goes, okay, limit again. This first 2 tends to 2x plus 2. This cannot be simplified further. Okay, so 2 plus 2 is equals to 4. You will see the Python code also for the limits. So again, the steps are simple. This is a repeated slide. Okay. Next slide, if we want to see differentiation and the integration in real time, and how will you solve it? So basic differentiation rule you need to know. For some of the examples, integration as the reverse process of the differentiation, and application of L'Hospital rules for interdeterminate form. So if you want to differentiate this particular function, how will you differentiate? So fx is equals to x3 plus 5x2. So we need to go the formula. So as we know, if it is differentiation x power n, then it is n x power n minus 1. So again apply here. It is 3 because this is n x squared plus 10x. So f dash x is this one. And if I talk about integration, so what is that? Xn dx. So you know xn plus 1 divided by n plus 1. So if you want to do the integration of fx dx, so what is that? X4 by 4 plus 5x cubed by 3. Okay. So similar questions is there, how to solve it. I have prepared slides 10 point by point so that you will understand how to solve a particular problem. So substitute the limit point and we got our result. Verify also, we solved this list. Now input output relation for the RLC circuit. That also we should know. RLC means resistor, inductor and the capacitor. Suppose you have one battery. This is resistor. This is inductor. This is capacitor. Okay. So this is C, this is N, this is R. So whenever we need to calculate the current across this inductor, so we need to know the formula. This I is equals to since we are talking about it. So I is equals to L into dV by dt. So since this is the voltage, suppose we know, then we need to calculate this I. Okay. And if it is a current that we know, so suppose this is the current V. So I across L T is equals to integration of L dV by dt. dV dt. Similarly, V across C is equals to 1 by C IT dt. So this formula you always remember. So whenever we need to calculate for the current for the across inductor, then we need to use this formula. And if you want to calculate the voltage across capacitor, then we used to use this formula. So now you may wonder when to use this formula, when to use this formula. So whenever there is a series circuit like this. So for the series circuit, we always have current. Okay. And whenever we have parallel circuit, then we have voltage because this voltage is same for all. Whereas this current IT is same for all. So what do you want? We have IT. So we need to calculate this. And okay. So suppose you have IT across the capacitor, and you are asked to calculate VT. So you're simply using this formula 1 by C integration of IT dt is nothing but 1 upon 1 microfarad. I is nothing but suppose it is given 5 power minus T dt. So 1 by 1 micro, matlab here it will go 6 10 power 6 minus T dt. And this is 10 5 into 10 power 6 e power minus t into minus. So this is minus 5 into 10 to the power 6 e power minus 6. Obviously the constant will come. So this is a constant. So constant can be represented anytime. So this is can be minus 5 e power minus 6 t. Sorry, minus t plus c. And this is in the micro voltage. Because 10 power 6, not 10, mega. So this will be the mega voltage. Because 10 power 6 has mega value. 10 power 6. Micro has minus 6. So step is also given, where K is a constant. The voltage across capacitor will be this. I hope this is understood to you. So if at any point of time you want to ask anything, you can stop me in between, you can ask. Now this is a very interesting question. Okay, just 1 minute. I'll have water. So in order to calculate for the unit step in the delta function, you should know the properties of a delta function. So I will tell you what are the properties. First of all, these are having the applications in signal processing. So if we talk about delta, we know that it is having t is equals to 12 infinity. Zero otherwise. Now if you want to shift to delta t minus 1, how will it look like? It is having, because since it is a delayed version, so it is having t minus 1 is having infinity, t is equals to 0, t is equals to 1, sorry, now 0 otherwise. But the area under, what will be the case? It is only 1 at this particular point. So if you integrate over t1 minus or t1 plus, then it is 1. Okay, so area will be 1. So since this is multiplied, and other than that, all the values are 0, only except at t is equals to 1, it is having some value. So whatever value, because the area under this particular thing will be 1, okay, at t is equals to 1, okay. So this is multiplied by ft, so t will be 1. So answer is f1, okay. If it is t minus 3, suppose, so answer will be f3. What if it is having t plus 3? So answer will be f minus 3. Okay. And this is represented in terms of property also. So if you talk about this property, this is called as one property. Okay. And delta function is used to model impulse inputs, while unit step function model sudden changes, because it is having sudden changes. And since I asked about what is the integration over utility, it is infinity. Answer I gave now only. Now, let us solve some problems. So since first week was not much heavy loaded, okay, it was basic maths, RLC circuits and all. But I want to solve the questions. These are the previous year questions, okay, so that even if it is easy, we should not ignore it, because some trivial things, if we ignore now, it may have we may have problem in the future. So let us start from question 1. What will the answer? The value of cos h j z is what? Let us wait for 1 minute. Anyone? Krishna, Kavya?
I think option
C.
B, ma'am.
Answer is C.
I think B, ma'am.
Yes, ma'am.
Okay. Good. Krishna and Kavya. So if we want to represent cos H, J, Z, so how it is represented in terms of Euler form? So if we say Euler formula, what is that? Cos H x is nothing but e power jx, sorry, e power x plus e power minus x divided by 2. Agree? And now x is jz. So cos h jz is nothing but e power jz plus e power minus jz divided by 2. And this is what? This is nothing but, this is what? Cos jz. Why? Because because cos theta is nothing but e power j theta plus e power minus j theta divided by 2. And even if you represent j, okay, so cos j theta, suppose. So this is cos minus theta plus cos theta divided by 2, which is not equal to cos hjh. 1. So tally 1 and 2, you will get answer as B. Very good. Okay, carried out. Now question number 2. Just now we discussed about properties of delta function. What will be the answer? Delta function is very, very, very important. Kavya, just now we discussed, right? So we are having delta 0.5 t that we can represent in terms of delta AT. Okay, so as we know, delta t is infinity at t is equals to 0, 0 at t is equals to otherwise. Okay, so simple way of representing is, it is infinity, this is t. Otherwise, it is 0. It is infinity. Now we also know integration over delta t is 1. We know integration over delta t minus a f t dt was what? Fa. Just now we discussed one property. The other property we discussed is delta t plus a ft dt is f minus a. Why? Because the only value where it is having the value or the integration over the area under that particular function at t is equals to a. In this case, it is at t is equals to minus a. Okay. Now, the problem here you are having is delta at. How will it look like? So, this is equals to 1 upon modulus a delta t. Okay. Why? Because it is doing compression or expansion. What it is doing? 0.5 is doing compression or expansion. Anyone? It is doing,
Compression.
since it is less than 1, so you are telling it's compression. Think logically. So here we are multiplying A, okay, over T, A. So what it is doing is whatever value at T you are having, previously suppose T you are having something infinity, and now it is having the same value as AT. So 0.5 T or delta AT will have the infinity as AT, not then other than T. So this AT is actually doing compression because T you are multiplying by A. So that value, with that value, it is having that value. Means infinity was previously at t is equals to 0. Now the infinity value is at t is equals to 80. So this is doing compression. In fact, as I told you, del t minus a was doing advance or delayed. This is doing advance. Because here time is negative or is subtracted by a, but how delta t is representing? So delta t minus a is represented as this particular value. This is a. So it is doing advance. So similarly, it is doing expansion. And the value and the way that how we represent is 1 upon mod of a delta t. This is the property. Okay. So accordingly, what will the answer? So 1 upon mod a is 0.5 delta t. This is 2 delta t. Answer is 4. So if this type of problem comes, I think you can solve. Now tell me, question number 3. What is even signal? What is odd signal? And cannot define or stochastic signal? What will be the answer? So if we talk about the logic of even and odd signal, okay. So even signal, symmetric about y-axis. So what does this mean? This means is if we define a signal x t, it should have property as xt is equals to x of minus t. Okay. And odd signal, it has the property of symmetric about origin. So this has the property of xt is equals to minus of x minus x. Minus. And any signal can be represented sum of even and odd signal. Okay, this is the way. Now, the given question is cos 3z. How will you determine whether it is even or not? Let us first try x of minus z. Tell me what will the x of minus z? Cos minus z. Do you know basic cos? So cos minus z is actually minus of cos z. Right? How? Because if you say e power j theta, e power j theta is equals to cos theta plus j sin theta. This is the polar form. This cos of minus z is equals to minus cos z. So accordingly, this is equals to cos minus cos 3 of z. So this is what? This is equals to minus x of z. So here it is representing x of z is equals to minus x of minus z. So this is odd signal. Any doubt? sorry, cos of minus z is not equals to minus, it is plus z. So it's even signal. Sorry. So cos of minus z is equals to plus cos of z. It is even. Sine of minus z is equals to minus sine z. So I got confused. So it is an even signal. But the only way how to determine is through this. And now you may wonder, it is lying in which quadrant? So uh, sine, cosine lies in second quadrant. Sine line in first quadrant, cosine line in second quadrant, tan line is third quadrant. So this is a basic math you need to say, you need to see. Uh, Sine of minus z is equals to minus z, whereas cos of z, because cos is actually an
No,
even signal. How? See, it is, whereas this. Okay, this is cos. Okay, so this is cos here with respect to y-axis. This is this. So this is symmetric with respect to y-axis. So that's why I remember this is the symmetric with respect to y-axis. So cos of z is equals to cos of minus z.
no. Cos
Yeah.
minus z equal to minus cos z. So cos is odd actually. So minus of
Co no,
cos
cos is
minus
not
z.
odd. Cos is a even signal. See, simply by seeing the graph only you can see it is symmetric with respect to y-axis, whereas sine is symmetric with respect origin. It is symmetric respect to origin. Sine 0 is 0, and sine of x is equals to minus sine of x. Sorry, minus sine of x is equals to minus sine x, whereas cos of x is equals to cos of minus x. Cos is even signal. See from the graph. And even if you want to verify with this by Euler form, let us verify that. Cos theta is equals to e power j theta plus e power minus j theta divided by 2. All of you agree? Now let's calculate cos of minus theta. Okay, cos of theta plus cos of minus theta by 2 is equals to what? Cos of minus j theta plus cos of j theta divided by 2. Is it not equal to cos of theta? It is. So cos is a even signal. Sine is odd signal. And the odd signal has property that x of 0 is also 0. Whereas an even signal x of 0 not equal to 0. So whenever we see the odd signal, first of all, we see whether that origin is equal to 0 or not. Because anyway, we are talking that symmetric about origin. And even signal, we are talking about y-axis. So simply by seeing this, we can say. Okay, cos power 3z is a even signal. Uh, any doubt, Dishan?
But as far as I remember, cos minus x should be minus cos x. Minus.
So you must have doubt, but you can clarify later also. You can see simply uh, the formula. Cos is always a even signal. So, okay, I'm moving to the next question. Tell me, what is the first order derivative of 2 power x? So, as we know, d by dx of e power x is simply e power x. What if e is not there? Instead, it is a. Do you remember the formula for d by dx of a power x? So, I'm giving you the formula d by dx of a power x is nothing but a power x ln of a. Okay. So d by dx of a power x is equals to a power x ln of a. So what will be the answer? So what will be the answer?
Option A, ma'am.
Answer will be first. Good. Moving to the next question. Just a second. So yeah, what will be the answer for this question? Limit x tends to 0, 1 minus cos x sine square divided by sine square x by 2. How will we approach? So as we know, in order to solve immediately for the limit, we just need to check whether we need to solve it or whether we can simplify it or not. So how will we simplify?
L hospital rule. So 0 by 0 form, so we can apply L hospital.
Yes, very nice. So the way of simplifying is whenever there's a zeros by zero or infinity by infinity or 0 by infinity or infinity by 0, we will use L hospital rule. So L hospital rule says that if you want to do 0, suppose whatever this is, 1 minus cos x sine square x by 2, we can derivate it. So let us derivate it. Limit x tends to 0. 1 minus cos x, 0. Cos x. What is the derivation of cos x? Minus sin x. Right? So 2 sine x by 2. Okay, because x by 2 I'm keeping 2 sine. And this is 1 by 2. Sin x ka derivation is x by 2. So this is limit x tends to infinity. Sin x divided by this is 2 sine. I'm keeping 1 by 2 as out. Sin x by 2 cos x by 2. This is limit x tends to 0. Sin x divided by 1 by 2. This is 2 sine x by 2 cos by 2 is sine 2 into x by 2. This is sine x. So sine x. So this goes. Answer is 2. How would I solve? You remember, I have used a simple formula. So derivation of cos x is nothing but minus sine x. Okay. Derivation of sine x is nothing but cos x. Okay. And the other thing that I have used is sine 2x formula. Sine 2x is nothing but 2 sine x cos x. So similarly, I have used here and this goes down. So this is answer is 2. Okay. So moving to the next question. And whenever this forms comes, you directly go and apply this L hospital rule and you check whether you can uh, whether you can solve this or not. We can also solve with respect to 1 minus cos x. So 1 minus cos x, if you know, this cos is some formula was there. 2 sin x or something, we can use it here. So 1 minus cos x is equals to sin x by 2. 2 sin x by 2. Yeah. So the other way to solve is 1 minus cos x is nothing but 2 sin x by 2. Whereas 1 plus cos x was 2 cos x by 2. So here this 1 minus cos x is there. So if you say solve limit x tends to 0, 1 minus cos x sine square x by 2. I'm writing the question again. So this is limit x tends to 0, 2 sine x by 2. This is sine square x by 2. So, okay, it's not solving through this. We have to apply a L'Hospital rule only. Sorry, this is square. Okay, yeah. I forgot the formula. This is square. This goes. This is 2. Yeah, this was square. So 1 minus cos x is equals to 2 sine square x by 2. I remember the formula from a trigonometric. Then 1 plus cos x is 2 cos square x by 2. So this goes directly and this 2. So either you can simplify it or you can use L'Hospital rule. It's up to you. The previous problem that we saw in the first beginning, second or third slide, that we have to simplify it. Okay. So either way, it is going to answer. Okay. So next question. It was directly taken from the last year question. So the question was this, because sir taught about Kirchhoff's current law. Okay. So the conservation of charge is which of the following? Kirchhoff's voltage law, momentum law, Kirchhoff's current law, or what? So as both of you told, Krishna and Kavya, that you have watched the lecture, what will the answer tell me?
Current law, ma'am.
Very true. So Kirchhoff's current law states that the total current, suppose it is entering a node, it's equal to the total current leaving the node. So sir taught in the classes, suppose this is a node and this is I and this is I1, I2, I3. So I is equals to, because it is entering, is equals to I1 plus I2 plus I3. And this is goes to conservation of charge. Okay, very nice, Kavya. Next question. The conservation of energy is Kirchhoff's voltage law, Kirchhoff's momentum law, or Kirchhoff's current law, Kirchhoff's mass law. Which of the following?
Voltage law.
Is it? Correct. Very true. So Kirchhoff's current voltage law says that the sum of all the voltage in a closed loop is 0. So if it is a V1, V2, somewhat suppose V1, V2, V3, V4. V4. So sum of in a closed loop, it should be closed loop. So V1 plus V2 plus V3 plus V4 should be equals to 0. Provided closed. Okay. So far so good. We have solved some of the questions. Now, moving to the next question. Okay. Tell me, it was straightforward. So the exponential function can be represented as a Taylor series expansion. What is a Taylor series? E power minus z. How can you represent? First, tell me e power z. It is 1 plus z square by 2 factorial plus z cube by 3 factorial. Is it? Then if we write in e power minus z, what will the answer tell me?
1 minus z plus
1 minus z.
Yeah, very good. So answer is B. So first week was basic maths. Second week onwards, we will have the complete signals and system questions. The basic maths was there. I have taken from there. Now, this question is very good. Let's solve this question. Tell me how will we solve? 0 to 1 sine 4x cos 3x dx is what? So let me solve. So do you know sine A cos B formula? So sine A cos B formula states that 1 by 2 sine A plus B plus sine A minus B. Okay, so if you take sine 4x cos 3x is equals to 1 by 2. Either 2 can be here or 2 can be here. So what is sine? Sine 7x plus sine x. Okay, now we need to solve it simply. So what was the question? 0 to 1 sine 4x cos 3x dx. it is 1 by 2 will come out. So 0 to 1 sine 7x sine x. Okay, so now tell me 1 by 2 minus cos 7x divided by 7 minus cos x, right? So 0 to 1, this is 1 by 2. So cos, so yeah, so minus cos, either we can write 1 here, 0 here. The either way will work. Okay, so this is cos, I'm keeping it plus here. Hmm? So cos 0 is 1 by 7 plus cos 0 is 1 minus cos 7 by 7 minus cos 1. Okay, so if we solve it, this is 7, this is 8 minus cos 7 by 7. Okay, and minus cos 1. We need to solve it. I don't know what you need to keep in the calculator. Just let me keep in the calculator. Okay, we know the way you can calculate and put either of the options. Maybe I don't know whether the options are correct or not. But yeah, the way to solve this only, we need to just keep the formula and solve it by the basic method. There should be pi or something. It should not be 1. Somewhere the mistake is there. So if it is pi, then definitely cos pi, suppose there, then pi cos pi is minus 1. Okay, so just keeping. Okay. So this is nothing but 1 by 2, 8 by 7 minus plus 1 by 7 plus 1. So this we can solve easily. 7, 8 plus 1 plus 7. And we can solve it further. That's not a problem. Okay, so integration we know. Now moving to the next question. Question number 10. Tell me how to solve. So do you remember this formula or the form? So this is from the engineering mathematics. So this formula, if we have the form that is 1 by a square plus x square dx is nothing but 1 by a tan inverse x by a plus c. This formula is very resembling. Okay, so just we need to keep the formula limit. So 1 by 4 plus x square dx is nothing but 0 to 1, 1 plus 2 square plus x square dx is nothing but 1 by 2 tan inverse x by 2, 0 to 1. So tan 0 is 0 because it is sine by cos, so it is 0. Tan inverse 1 by 2. So what is the tan inverse 1 by 2? It is tan inverse 1 by 2. It's pi by 2. Right. It's pi by 2. Okay. So let us tally. It's pi by 4. 7 by 8. You need to calculate. 7 by 8 should be speed, voltage law, current law. 2 cos cube is the even signal. Okay. Even signal. We also calculate as true. So far so good. We have solved several problems, 10 problems we have solved. We have solved the logics, how to solve the particular problem. We saw some of the logics, RLC circuit, L hospital rule. We saw phasor form, current form, some of the Python codes also we saw. Now I'm going back to the Python course to show some of the other problems. Okay. So any doubt, just let me know. Uh, So first question we saw, uh, this Bayesian form, complex numbers, addition, subtraction, multiplication. This we already saw. Now I'm going to the last problems. Delayed in an advanced version. Okay. So let us see first this problem. We need to generate the unit step function. Okay. Using NumPy with functions. Okay. So as we know, these are the simple import libraries, and pyplot is used for plotting and NumPy is for the array. So if we define the unit step NumPy, simply where t greater than or equal to 0, it is 1, otherwise 0. So np.where, this is a predefined function and I'm using that. And the custom, if we want to keep some of the values, suppose t as an instance. Okay, so this is zeros where it is t, other than t it is 0, otherwise it is 1 if t greater than or equal to 1. Sorry, 0. So if we say delayed version, so we are keeping some of the delayed version as a is equals to 1. So time delay before the step occurs. Okay, it's simply plotting the unit step function. Okay, title and label. So I'm defining t start as -5, number of points is 1000, because these are all acting as a random variables. Okay, then plotting the delayed unit step function. Let us see. So this is a unit step function using NumPy, but this is a simple function, 0. And since this is a band limiter, otherwise in practice it is not band limiter. It is starting from minus infinity. Okay. And unit step function using custom function. This is delayed version. So at t is equals to 1, I have kept it. Delayed means it will go up. Scaled version, a is equals to 3. And since it is going above than that, and it's not plotting because 5 must be some value was there, and this is not showing the y-axis. And this is a scaled and delayed version. So scaled 2 and delayed is -2. So how this looks like in practice. And this is very interesting, this RLC circuit. So as we know, the voltage across capacitors was what? 1 by C integration of ICT dt. Yeah. So this is series RLC circuit. And this is, if this is the current, how the differentiation looks like. So differentiation is like this, dotted red. Okay. And if we say the voltage of that resistor is Y, VRT, because it's series RLC. Okay, so series means the current will be same, but the voltage will be different across different components. So that's why this plotting the voltage. Otherwise, if we plot the current will overlap with each other because it is a series. So you may see that the voltage across capacitor is the highest. You may wonder why. Because it is just an integration. Integration means this is just summing up to what time. So initially it started, then summing like that. Whereas inductor voltage is lower than this because it is a differentiation version. So this is like opposite. We can see that's why the voltage across inductor and the resistors are 90-degree phase apart, as we can see from the figure also. Okay, and not sorry, 90 degrees, it's 180-degree. I would like to correct my word. This is a 180-degree, it's not 90-degree. 90 degrees for the sine and cosine. This is not 90-degree. But if you say about the voltage of a resistor, it's almost same because it doesn't care about that. It's just V is equals to voltage equals to current into R. V is equals to I into R. Sorry, I is equals to V into R. V is equals to I by R. So this is I divided by R. Okay. And numerical evaluation also is somewhat saying at t is what with what time it's showing. So progressing. Sir taught about in the class as a series RLC circuit, but we also saw some of the parallel RLC circuit. The parallel RLC circuit in the sense is the voltage will be same. So when you have the voltage, you need to calculate the current. So current we have to calculate using this integration function. Okay. Suppose we have seen as suppose one of the function is fx is equals to 2 power x. What will the integration? So it is as we saw in the problem also 2 power x ln2. So this blue color is function and the differentiation is red color and integration is this one. Okay. Similarly, if you want to see some of the problems, simple. So in normal form, uh, the derivation means slope. So wherever you're finding the slope, that derivation means. So if we say this, the blue color is actually the function, uh, this particular part, the red color, so it's what's showing is, it's trying to find the slope at this particular edge. Not all, but at this particular edge, it's trying to find it, the slope, because it is actually the change in y divided by change in x. So the change in y, if we say this, suppose this particular point, the change in y is this one, divided by change in x is this one, because this is what it is showing. Whereas integration is just the integration, like it will show the summation function. And we saw the limit part. So the limit part, this is a very common and well-known expression is sin x by x. So if limit tends to x is equals to x tends to 0, so sin x by x is 1. So that's what it's showing. And if we talk about left-hand limit, right-hand limit, so it is equal to left-hand limit, right-hand limit when it is a continuous function. And if it is not a continuous function, then you will have the slight disruption. The left hand limit will not be equals to right hand limit. So whenever that left hand limit is equal to right hand limit, we calculate, we say that it is a continuous function. And we saw this as earlier also. This is the phasor form of the complex numbers and how suppose Z1 is this one, Z2 is this one. This is showing the product and this one. And this is sine cosine and 90-degree phase shift is there. And how will we define the sine and cosine? You always remember it is a cos omega t plus phi and a sine omega t plus phi, where into e power j phi is actually the way of in the phasor representation. So a e power j phi is same for cos and sine. The only difference here it will create is phi and a. And this is a complex number with different phase and magnitude as we already saw. So I think if you have any doubt, just let me know. So this was part of week 1 content, and I will keep the same type of content for the week 2. And I hope if you join this class, it will be interesting for you. And if you have any doubt, you can just after watching all the week 1 videos or the week 2 videos, you can come and revise your concepts in this class, 2-hour class. And I'm here to help you. Even if you can mail me if you have some doubts, I can cover in the class. That is a motto of these live classes. And also, I would request you to give the feedback in the feedback form for the live classes. It is helpful for us to get the grades. So this was the content for the week 1. And if you do not have any questions and queries, then you may leave the class. I think I have covered almost all the things for the week 1. I will share these notes in the drive folder. I hope you know which drive folder I'm referring to. It's a drive folder that the NPTEL team share with us, and the same drive folder will go to you. I have covered 10 questions and Python codes associated with it. And since the content was not much for the week one, so I'm just stopping 10 minutes before the class timing. And even if you have doubt, I can stay here. You always remember the quadrant part. It's very, very important in order to calculate the theta. And if we say some keynotes or the conclusion points, so the first conclusion point was even and odd signal. So any signal can be represented in terms of sum of even and odd. The second conclusion point was in order to calculate the derivation and the differentiation or the integration, you need to first simplify it, then you have to calculate because it will be very difficult. And the third point was a limit. So you have to apply the L-Hospital rules as we have applied. Okay. And either way you can go through. The second way also you can go. At the basic laws, you should know Kirchhoff's current law, voltage law. Okay. And the third was the simplified expressions for e power minus z and all. Then again, the integration was there. Then some of the formulas for the integration and the differentiation you should know. These were the answers. I will share the Python code with you uh, for the visualization purpose in the same drive folder. You may refer to that. And since the class content, the week one content was basically the maths and all, so if you want to learn further, you can actually try replicating the same thing which I have done for for every questions or every part. So that will be helpful for you for sure. So thank you so much for joining. I would like to take your leave, but I will definitely upload the video and the course content and the Python code in the drive folder. So we are left. Dishan, do you have
Thank
any
you.
doubt?
No, ma'am, thank you.
Yeah, thank you. Yeah.